Hello guys, welcome to this new video about mesh analysis method. Solve the problem number 6. In this video, I will demonstrate a simple method for applying mesh analysis in circuits that contain only linear resistors and independent voltage sources. Given the electric circuit with R1, R3 and R5 are all equal to 30 ohms, R2 and R4 are equal to 10 ohms, and we have an independent voltage source Vs is equal to 12 volt. The question now is to calculate the mesh currents IA, IB and IC. Let's go to the solution. We can observe in these circuits that only resistors and independent voltage source are present. The mesh current equations can be obtained by inspection when a linear resistive circuit contains only independent voltage source. Those mesh current equations can be expressed in matrix form as follows: R multiplying by I is equal to V, where R is given by this matrix and I is the vector given by IA, IB, IC, and V is a vector given by V1, V2, and V3. We have R11, R22, and R33 are the sum of the resistance in meshes 1, 2, and 3. R12 and R21 are the negative of the sum of the resistance in common with meshes 1 and 2. R13 and R31 are the negative of the sum of the resistances in common with meshes 1 and 3. And R23 and R32 are the negative of the sum of the resistance in common with meshes 2 and 3. Finally, V1, V2, and V3 are the sum taken clockwise of all independent voltage sources in mesh 1, 2, and 3 with voltage rays treated as positive. Let's go to apply all this in our example. We have here our resistance value. The mesh current equations can be obtained or can be expressed in matrix form as follows, where R is given by this matrix, and I will explain how we obtain this matrix. We said that R11 is the sum of the resistance in mesh 1. Let's go to the mesh 1. We have only R1 and R2. That means R11 is R1 plus R2 is equal to 40. We go now to R22 is the sum of the resistance in mesh 2. R22 is equal to R2 plus R3 plus R4 is equal to 50. And R33 is the sum of the resistance in mesh 3. That is equal to R4 plus R5 is equal to 40. We have now R12 and R21 is the negative of the sum of the resistance in common with mesh 1 and 2. We can see here that this mesh 1 and this is mesh 2. The common resistance is R2. We have negative 10, negative R2. We go now to R13 and R31 is the negative of the sum of the resistance in common with mesh 1 and 3. This is mesh 1 and this is mesh 3. There is no common resistance between mesh 1 and mesh 3. That's why we have here 0 and here is 0. We go now to the last one is R23 and R32 is the negative of the sum of the resistance in common with mesh 2 and 3. This is mesh 2 and this is mesh 3. The common resistance is R4. Then we have negative R4, that is negative 10, negative 10. And we have I is given by IA, IB, and IC, and the vector V is given by negative 12, 0, and 12. And I will explain how we obtain V. We said V is the sum of all independent voltage source with voltage raise treated as positive. Let's start here. If we go in the clockwise, we have here voltage drop. That means here we have negative Vs. That's why we have negative 12. If we go to B, there is no independent voltage source. That's why is 0. If we go to mesh 3, we go in the clockwise direction. We go from negative to positive. We have voltage raise, then it should be treated as positive. That's why we have here plus Vs. In order to simplify the calculation, we divide matrix R by 10 and the vector V by 10. Let's now apply Cramer method in order to solve this problem. Let's start first with determinant of R is equal to 4, and we cancel the first row and the first column. It's over only 5, negative 1, negative 1, and 4, minus negative 1, and we cancel the first row and the second column. We have determinant of negative 1, negative 1, 0, and 4. 5 multiplying by 4, that's 20, minus negative 1 multiplying by negative 1, all multiplying by 4 is equal to 76, and we have minus 1 multiplying by 4, minus 0 multiplying by negative 1, we have negative 4. 76 minus 4 is equal to 72. Let's go now to define matrix R1. We obtain matrix R1 by replacing the first vector or the first column of R by vector V. The determinant of R1 is equal to negative 1.2. We cancel the first row, the first column. We have determinant of 5 minus negative 1, negative 1, and 4, plus negative negative 1, and we cancel the first row, second column. We have determinant of 0, negative 1, 1.2, and 4. 5 multiplying by 4 minus negative 1 multiplying by negative 1, all multiplying by negative 1.2, we have negative 22.8, plus 0 multiplied by 4 minus 1.2 multiplying by negative 1, we have 1.2 is equal to negative 21.6. We go now to define matrix R2. We obtain matrix R2 by replacing the second vector of R by vector V. The determinant of R2 is given by 4, and we cancel the first row, first column. We have determinant 4 multiplying by determinant of 0, negative 1, 1.2, and 4. Minus negative 1.2, that's 1.2, and we will cancel the first row, the second column, the first row and the second column. We have negative 1, negative 1, 0, and 4. That means determinant of R2 is equal to 0 multiplying by 4 minus 1.2 multiplying by negative 1 multiplying by 4, that's 4.8, and we have negative 1 multiplying by 4 minus 0 multiplying by negative 1 multiplying by 1.2 is equal to negative 4.8. That means determinant of R2 is equal to 0. We go now to matrix R3 is obtained by replacing vector 3 or column 3 of matrix R by V, and we go to calculate determinant of R3 is equal to 4, and we cancel the first row, the second column. We obtain 4 multiplying by determinant of 5, 0, negative 1, 1.2, plus minus, that means 1 multiplying, and we cancel the second row, the first column. We have determinant of negative 1, negative 1.2, negative 1, and 1.2 is equal to 5 multiplying by 1.2 minus negative 1 multiplying by 0 multiplying by 4 is equal to 24, and we have negative 1 multiplying by 1.2 minus negative 1 multiplying by negative 1.2 is equal to negative 2.4. That means determinant of R3 is 21.6. Now we can easily calculate IA is given by determinant of R1 over determinant of R is equal to negative 21.6 over 72 is equal to negative 300 milliamps. IB is equal to determinant of R2 over determinant of R is equal to 0 over 72 is equal to 0 milliamps. And finally, IC is equal to determinant of R3 over determinant of R is equal to 21.6 over 72 is equal to 300 milliamps. After we finish calculation, we have done simulation using SPICE simulator in order to verify our calculation. Let's go to see the circuits in SPICE simulator. Here is the circuits done by SPICE simulator. We have here R130, R210, and we have our voltage source Vs is 12 volt, R5 is 30, R410, and R3 30 ohms. We go now to analysis, DC, analysis, calculate nodal voltage. We can see here that IB is 0 amps, IA is negative 300 amps, 300 milliamps, and we have IC is 300 milliamps. Those values are exactly the value we have done by calculation. Keep in mind that this method is valid for circuits with only independent voltage sources and linear resistors. If you like this video, don't forget to subscribe and share this video. And if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will answer you as soon as possible. Have a nice day. Bye bye.